Distinguished guests, ladies and gentlemen, a very good afternoon from Asia CCUS Network Secretariat, and a warm welcome to all panelists and participants who are connecting virtually from around the world. Welcome to the Asia CCUS Network Knowledge Sharing Conference, which this time will bring out the topic of Huff and Puff CO2 EOR, small field solution to improve production and reduce emission. My name is Marteighianti, Research Associate for Energy Research Affairs from Economic Research Institute for ASEAN and East Asia, ERIA. And it is my great pleasure to be your MC today. With us now, we have representative from PERTAMINA, Indonesia, Ms. Mary Marteighianti, Vice President of Research and Technology Innovation, and Ms. Debby Halinda, expert in research and technology innovation, who will share with us PERTAMINA experiences on Huff and Puff CO2 EOR. As project collaborator with us, Mr. Kazuaki Mikami, Reservoir Engineer, Deputy Director, Subsurface Division, Hydrogen and CCS Project Department from Japan Organization and Metal Energy Security, JOGMEC. We'll later share his insights during the commentary and discussion session. Before continuing to the main agenda, I would like to briefly explain about housekeeping rules. During the presentation, all participants can drop questions in the Q&A box on your screen, and we will discuss them during Q&A session after commentary session. Without further ado, it is my great pleasure to invite Mr. Shigeru Kimura, Special Advisor to the President on Energy Affairs, ERIA, to giving his welcoming remarks. Mr. Kimura, the floor is yours.
Thank you very much, Diane, and thank you. Good afternoon, all the online participants from the members and supporting members of the Asia CCUS Network, as well as the ordinary participant. First of all, on behalf of the Secretariat of the Asia CCUS Network, I'd like to express my thanks to all of you for your participation to the ASEAN Knowledge Sharing Conference today. And secondly, I would deliver my much appreciation to all of you for your kind and usual support to the ASEAN activities. Today, we ASEAN would like to introduce the CO2 EOR technologies being promoted by the PERTAMINA, Indonesia, in the west part of the Java, with strong support of the JOGMEC. I am sure that CO2 EOR is evaluated as initial technologies to promote CCS, including CO2 storage in basin layers. In addition, cost of the CO2 EOR might be lower than basin-basis CCS, as well as the create economic benefit to increase oil production. Thus, CO2 EOR is highlighted currently, and it is many benefit for the members and supporting members of the ASEAN if we would hear experience and the expertise of the CO2 EOR from the actual entities such as the PERTAMINA. In this regard, we ASEAN Secretariat would like to invite two excellent speakers from PERTAMINA. One is Ms. Marteighianti, Vice President of Research and Technology Innovation PERTAMINA, and the other is Ms. Debby Halinda, expert of the Research Technology Innovation PERTAMINA. As well as we'd like to also invite Mr. Kazuaki Mikami, Reservoir Engineer, Deputy Director at Subsurface Division, Hydrogen and the CCS Project Department, JOGMEC, as commentators. As the presentations, the moderator, Dr. Gusti Sitivan, I will read the Q&A between the speakers and the online audience. Sorry, after the presentation by the two ladies, Gusti will lead the Q&A session as a moderator. Thank you, Gusti. And again, thank you very much, all of you who here for your participation to this knowledge sharing conference. And I hope this knowledge conference will be useful and fruitful for the all the audience. Thank you for your attention, and I back to the Dian. Thank you very much.
Thank you so much for your welcoming speech, Kimura Sensei. In proceeding to the next session, I'm now inviting Dr. I Gusti Sornaya Sideman, area expert on CCS CCUS, as our moderator for the next session. Hence, I will pass this session to Dr. Sideman. Please, the session is yours. Thank you.
Okay, thank you, Dian. Good afternoon, distinguished participants. Good afternoon, our distinguished speaker, Bu Mary, Bu Ilda, and also Mr. Kaswaki Mikami. Welcome to the Asia CCUS Network Knowledge Sharing Conference. Knowledge Sharing Conference is one of Asia CCUS Network program in knowledge sharing to promote collaboration and cooperation on the development and deployment of CCUS and to accelerate decarbonization in Asia region. Other ASEAN mission to conduct research, study on technical, economical, and legal standard of CCUS and to all capacity building, training, and workshop. Asia CCUS Network was established upon endorsement of cooperation initiative led by Japan and ERIA at the 14th East Asia Summit Energy Minister Meeting. The East Asia Summit and Summit is a consist of 18 countries, including Russia and United States. The Economic Research Institute or ERIA assigned to run the ASEAN Secretariat. Our topic for the Asia CCUS Knowledge Sharing Conference today is Huff and Puff, CO2 EOR, small scale solution to improve production and reduce emission. I think there are two types of CCUS EOR, as we know, CO2 flooding and Huff and Puff. Huff and Puff is basically well stimulation technique in one well, which composed of mainly three states. First, inject CO2 into the single producing well, or we call it Huff. And the second step is shut in the well to allow CO2 to dissipate and dissolve. And the third step, produce the well back or called Puff. Huff and Puff has been known since 60s, but the development of the technology is relatively slow due to available easier and cheaper to produce resources and lack of CO2 resources. However, since most oil field in Asia, especially now depleted, Huff and Puff bring a new alternative to commercialize the small field and unconventional resources into production. I think we will hear from the distinguished speaker the possibility of this technology for our future. Without further ado, I would like to invite Bu Mary and Bu Debby to start the sharing. Bu Mary, please, time is yours.
Thank you, Pak Gusti Sideman, for the introduction. Should I start directly?
Yes, please. Yes,
okay.
Please.
Okay, thank you, ladies and gentlemen. Good day to all of you. Hope you all in a very good condition right now, so that we can get benefit from the sharing session today. And thank you also for the ERIA and the team, for inviting me to this session and share our experience in the Huff and Puff CO2 injection in Jati Barang field. Let me introduce myself. My name is Marteighianti, as mentioned by President before. I'm right now in charge as a Vice President of Upstream Research and Technology Innovation, PT PERTAMINA Persero. Okay, maybe next. Okay, let me start this sharing with the commitment of PERTAMINA on the net zero emission. Commit for this NZE net zero emission, and this commitment is implement in the put in the charter, which is signed by the CEO holding and also the subholding. And in continuation of this commitment, next slide, we put several strategic projects as our portfolio. There are 7 here, and part of it is CCS and CCUS implementation, and also the emission reduction and the carbonization, which is the 2 initiatives, important initiatives to reach our goal in the NRE's projects. To conduct our projects for this NRE initiatives, we have several partnership. We conduct with partner, and as you can see here for the CCUS, CCUS, most of it is companies from Japan, as you see, and one of it is JOGMEC, which also involved in this Huff and Puff in Jati Barang field. Okay, now I would like to give you an overview about PERTAMINA's working area, where we conduct the study research for the CCUS all over the working area. Start from regional 1 and then regional 2 in Java, regional 3 in Kalimantan, and also regional 4 in Eastern Indonesia. We have studied almost in all of this area. The next slide, you can see that our CCS CCUS initiative is there are 9 of it. Actually, there are several others than this one, but this is the 9th initiative that quite give good progress. And one of it is the CCUS CO2 EOR Jati Barang that we just conduct by Huff and Puff. And this one we partnership with JOGMEC. Okay, this is the Jati Barang field overview. As you see here, Jati Barang is located in the West Java, and the operators is the PERTAMINA EP Zone 7. It's discovered in 1988, and the current production is about 9,000 oil, with the kawan quite high, 96%. The field, it's discovered in 1968, and then we drilled several wells and one of it that the Jati Barang, the one that we tried to do the one that we did the Huff and Puff CO2 injection. For the CO2 EOR Jati Barang, we have a comprehensive plan, to do the CO2 EOR, and we start this initiative in 2019, where we study the geomechanic and also the static remodeling. And then in 2020 and 2021, we conduct the CO2 EOR subsurface and also surface study. And finally, we did, and lately, just now, we did the Huff and Puff CO2 in October 2022. Next, we plan to do the pilot for this CO2 EOR, and then continue with plan to do the full field, in 2031. As the title of the sharing today is the Huff and Puff CO2 injection, we have a main objective for this one. There are two main objectives. One is as an initial step to use CO2 increase in the production of petroleum in the Jati Barang field, and also emphasize the PERTAMINA's decarbonization target. And the second objective is to confirm the performance of well and reservoir response of CO2 injection, and we will use it as an input of the development of full-scale EOR project. To conduct this, when we conduct this Huff and Puff injection, we collaborate with JOGMEC, and the partnership scheme is that PERTAMINA doing the operation, for the Huff and Puff, and then perform the injection operation in safe and efficient manner. And JOGMEC cooperate on CO2 injection design and sharing knowledge, sharing experience, and post-test analysis, and also share costs. Next. Okay, before I come to share the Huff and Puff CO2 injection, what we did last year, let me give some general information about the mechanism or method of the Huff and Puff CO2 injection, where there are three stages for these activities. Where first we do the Huff, where we inject CO2 into the well. This activity takes about 2.5 days, and then we start soaking the well. We close the well and soak for about 1 to 2 weeks. In this stage, we expect that the oil phase swells in volume and intermediate hydrocarbons extracted into the CO2. And after that, after the 2 weeks, we start production stage. We start produce the oil, and as a result of CO2 injection. Sorry, for this one, we monitored and produced about 3 months. Okay, next. Okay, there are several steps there, or what do you call? Well, when we have a plan to do the injection test, we do several steps to accelerate the success of field trials, where we need to enhance our understanding of the complexities and also challenges of that pilots or the activities in implementation. such as we need to set a pilot objective, as mentioned before. For this Jatibarang, we set the pilot objective. This is important step, yeah. And then we need select a pilot location where start from this, we start do the evaluation and some simulation from the data that we have. And after that, further we start design a pilot. Design pilot, it's involve several cross function and also cross expertise. And we also need to ensure measurable and definitive result there. So that after that, after we do the measurable definite result, we also need to plan the surveillance so that we understand where we go and what happened during the implementation. And of course, learning summary is also important so that we know what the takeaways that we can have, lesson learned that we can take from these activities. And also important that we pass the stage gate, yeah, like technical, where we do several studies and simulation and calculation, and we confirm that we got support from the business units, and also confirm about the cost, yeah, and regulatory or approval from the government. And we also see that several advantages when we conduct the implementation or pilots, yeah, with collaboration with partners, where we can share cost and also risk and broaden our expertise. Next. Okay, this is for the half and puff CO2 injection. Give you some brief information, yeah, about the CO2 source, transport, and injection. The CO2 source is from Subang field, where we have CO2 produced, yeah, from that field. It's about 100 kilometers from Jatibarang field. And at that time, when we conduct the half and puff, we used trucking as a transport. And for the CO2 injection itself, the injection is in a gas phase, and the volume is 200 ton totally, yeah, for the 2.5 days, and rate is about 80 ton per day, where the pressure is about 500 psi, and the stocking period is about 7 days. For the technical explanation later on will be explained by Ibu Debby. Next. Okay. Okay. I can say this is the sequence or timeline, yeah, when we conduct the injection. Actually, the discussion is start in early 2022, and we start discuss internally and see the possibility, the data required, and also the data availability. And then we start also seeking a partner. We discuss, introduce, and also discuss with several potential partners. Most of it is from Japan. And we are fortunate that we met JOGMEC, yeah, in I think about May, yeah. And then start May, we discuss, explain our plan, our objective, and we come into conclusion agreement in August 30th during the G20 event, yeah, in Bali. where we signed the GSA to do the Huff and Puff CO2 injection in Jati Barang. After the GSA, as you see here, from August to September, we start prepare for the injection study deeply and thoroughly, and then finally we conduct the kickoff ceremony and also the injection in October, and followed by soaking and production in November. This is for the GTB 161 well GTB 161, and then as I mentioned before, that we continue with the learning summary. We take a lesson learned from this GTB 161 and start conduct the second well, GTB 137, and in late December, and start production in January. We also conduct the lesson learned, the learning summary for this well GTB 137. Okay, to give you a footage, next, visual feeling about what we are doing during the ceremonial and also the injection of CO2 in Jati Barang. I will share with you the video, so you can watch the video and see the visual.
PERTAMINA as collaborator for the CO2 injection project in Jati Barang to oversee the strategical collaboration with all related parties such as JOGMEC, SKK Migas, and Ministry of Energy and Mineral Resources Indonesia. SKK Migas and Ministry of Energy and Mineral Resources Indonesia as government representative is responsible for formulating and conducting policy in the field of development, in which for the future CO2 project of CCS or CCUS implementation will be one of the major support. JOGMEC is a strategic partner of PERTAMINA for a net zero carbon society and engaged in the CO2 injection project in Jati Barang as a part of Asia Energy Transition Initiative or AETI, promoted by the Ministry of Economy, Trade and Industry Japan. Natural gas contains approximately 23% CO2 produced from the production of PERTAMINA EP Subang wells in the process through the Subang CO2 removal plant to produce sweet gas. CO2 gas from the separation of CO2 removal plant is processed through the liquefaction plant into liquid CO2 and stored in storage tanks. Liquid CO2 is transported through ISO tank truck to Jati Barang field for injection CO2 Huff and Puff at Jati Barang well 161. Prior CO2 injection into the well, liquefied CO2 first will have to be heated through several steps. At the first step, CO2 ISO tank will be connected with high pressure pump to transfer liquefied CO2 to evaporator. In evaporator, the CO2 will be heated and temperature will increase from -20 degrees Celsius to 15 degrees Celsius, transforming CO2 from liquid state into gas state. CO2 will then flow to electric heater to be heated further. Here, the CO2 temperature will continue to rise up to 25 degrees Celsius, which is designated target from simulation model to achieve optimum Huff and Puff result. Next, gaseous CO2 is injected to a depth greater than 1,100 meter underground at well JTB 161. CO2 travels down to the wellbore to a determined location within the carbonate reservoir formation, as the injected CO2 will mix with the oil formation. The oil will swell and reduce the viscosity, allowing the oil to flow easier in the formation. The injection process will continue until 200 tons cumulative CO2 injection achieved. The well will then be closed for soaking period. After that, the well will be opened and put back into production to measure oil production increase and trapped CO2. As an energy company, PERTAMINA has a great responsibility to be a pillar of achieving net zero emissions in the country with the principles of affordability and fairness. PERTAMINA targets to reduce carbon dioxide or CO2 to 81.4 million tons by 2060. PERTAMINA would like to acknowledge JOGMEC as strategic partner for this project collaboration. As we all know, no innovation without collaboration.
Okay. I hope you enjoyed the video. Alhamdulillah, thank God. After the two injection, the two well injection, we got a very good result, where for the GTB 137, we got production rate increase about 370%, where in the beginning the production is about 10 barrel oil per day, and then after the half and half, after the CO2 injection, the production increased up to 47 barrel oil per day, and water cut is decreased about 30%. We used about 218 ton CO2 totally. And then for GTB 161, it's also give a very good result. The production rate increased about 227%, and where the beginning the production is about 22 barrel oil per day, and then it's increased become 72 barrel oil per day, where we use for this field we use 250 tons of CO2, and water cut is decreased about 23%. Okay, next. Well, several proposal approval scheme for this initiative. As we know that there is a permit about the implementation of CCS CCUS already deployed, and this is a good sign that government has also commit for the net zero emission through CCS CCUS, where we see that from this permit, the proposal of CCS CCUS is proposed by contractor, and then will be evaluated by Migas or BPMA for the Aceh for the POD, and give the approval by SDM, Minister of the SDM, for the POD or the amendment of the POD. After the POD approved, then the contractor carried out the implementation of CCS CCUS, with the provision of the law and regulation. And if necessary, the contractor may also propose the amendments to cooperation contract to the minister through SKK Migas or DPMA. For the CO2 EOR itself, actually SKK Migas already have the, we call it pedoman tata kerja, or the regulation, which is PPK 058, about the improvement of recovery factor through pilot tertiary recovery activities, which include the pilot of EOR, in this case is EOR, where then SKK Migas will do the evaluation and give a recommendation and also the approval for the pilot of EOR. after the pilot is approved, then we can the evaluation of the EOR project and minutes of meeting will become as an output, and also the recommendation and letter concept and kickoff, for the output. This will come to degree of the head of SKK Migas. We see several key takeaways for this injection project, such as we see that management commitment on the net zero emission through CCUS initiative is in place, and also the government support Ministry of Energy and Mineral Resources and SKK Migas, and we also adopt the international cooperation on sharing knowledge, expertise, and also funding. Partnership also share the cost and benefit and sharing risk, and to build required technology capability. From the activities, we take several technology improvement and optimization, which could reduce the capex and also opex. Finally, from these 2 wells that we conduct, we got the data confirmation and validation, where this data we can use it for the next stage, which is for the full field CO2 EOR. Thank you so much. That's from me right now as introduction for what we did in the CO2 injection Huff and Puff in Jatibarang, and this is several pictures during the ceremony and during the injection, the first injection, which also include in the video that you watched before.
Thank you, Bu Debby.
Thank you. Next will be delivered for technical by Ibu Debby. Thank you.
Bu Debby, please. Time is yours.
Thank you very much, Ibu Mary, Sidemen, and I would like to express my acknowledgements as well to our partners here, our project collaborator from JOGMEC. In addition to what Bu Mary had been shared before, what amazing presentations. This is like a brief summary of what we are doing for the Huff and Puff in Jatibarang. For the continuations of the sharing from Ibu Mary, I would like to share some technical presentations that we had, and probably will have a additional benefit for all of you that attend here. Then please let me share this to all of you right now. I would like to introduce first myself, is Debby Halinda. I'm at the same team. I'm reporting to Ibu Mary Marteighianti, and I'm in production research of ASEAN Research and Technology Innovations. So, so sorry. Apologize, I'm having some, I need to check. Why? Okay, wait, sorry. Apologize for some okay. This one will be our sharing on behalf of our team RTI as well from PERTAMINA EP. I would like to share some technical explanations about what we have done for the CO2 injections Huff and Puff in Jati Barang field. Actually, this footage, the visualizations of the pictures there is the actual pictures that we had in Jati Barang. So if you are thinking about how we deliver the injections of the CO2, actually the pictures that you are seeing, that is the ISO tank that's full with the CO2 that we delivered or we injected into the wells. This is the well of GTP 161 as a footage visualizations. So by today, I would like to give you some brief presentations online. It will be consist of 5 agenda that will be include the introductions, timeline, main injections, how about the operations activities, and as well the challenges. So at the right one, that is the GTP 161 as the first well that we are doing the injections for the CO2 Huff and Puff. So for the introductions, I would like to go directly for the Jati Barang first overview. Previously it's been delivered and it's been presented as well by Ibu Mary. So I would like to go directly for the background and the objective on why and how we were choosing to do the Huff and Puff operations in the Jati Barang field. So as a background, as we saw at the first presentations from Ibu Mary, this Huff and Puff is, we are do that for our first step before doing the full-scale pilot, in which as a part of the proof of concept, the CO2 injections, we are choosing to do that using the Huff and Puff method, in which one of them is due to the CO2 requirement is much less, as well the complexities for the CO2 Huff and Puff is much more feasible to perform in our locations in compare with the pilot CO2 injections, in which for the CO2 Huff and Puff, we are using only the CO2 equipment services, as well the CO2 liquid as the consumables in comparisons with the CO2 pilot, in which we do some flow line installations. So, and then after the background, the objective of the CO2 Huff and Puff would be we do to obtain some reservoir injectivity data. As well, we want to have some how the effect of the CO2 injections to our reservoir, our oil reservoir, in which consists of how the physical properties changes, as well how the oil saturations and how the behavior and the phase changes during the CO2 injections operationally. And then as well, in addition to that, we want to have we will have some oil recovery or some gain of productions after we were doing the CO2 Huff and Puff. It's been mentioned as well by Ibu Mary that fortunately, after we are doing the 2 injections of Huff and Puff in these 2 wells, we are seeing a positive response of this CO2 Huff and Puff. And then in addition to the objective, we want to have some effect. Is there any effect for the any tendency of any corrosions while we were doing the Huff and Puff, in which if in the very short period we were having some corrosions, it means when we were doing the CO2 flooding, we might to have more severe corrosions in which we need to mitigate prior to do some full field scale. And for sure, at the last objective that we want to have is this will be a basis of our technical evaluations for a further massive field scale implementation plan for a field scale one. So the next one, I would like to have some brief overview about what exactly our completions diagram or well schematic that we are doing. In both of the wells that we are having, the locations for the wells is actually at the red one, as well as the gray one over here. So the typical of those 2 wells is actually will be considered as the vertical wells, in which we are doing all the operations is through 3.5 inch of the tubing. And then so that we are covering the annulus with the packer, as we can see over here. And then we go through directly for the CO2 injections bullheading through the tubular injections, that 3.5 one. So some brief summary of how the behavior of the reservoir properties that we were having in Jati Barang for both wells. The reservoir pressures would be around 750 psi, with the reservoir temperatures in the range of 20 degrees Celsius. So for the range of the porosities from those two wells would be around 25 to 30% of the porosity. The permeability is quite ranging in this reservoir. Both of the wells are accessing or injecting the same reservoir, which is what we call this lapisan F, or the F reservoir. The range of permeability would be in the range of 30 to 150 millidarcies. As been mentioned before by Ibu Mary, that the initial oil rate before the injections would be 10 BOPD for GTP 137 and then 22 BOPD for 161, with the range of the water rate is around 90% of the water cut. So then, actually, this is for some for a reservoir engineer. This is probably one of the basis design of what we were doing for the Huff and Puff CO2 injections design in Jati Barang. The left, the tables. This is actually our first design to attempt for both wells. So the soaking period as well the incremental oil is relatively the same. We are doing the injection phase in the gas phase. The volume of the injections for the first design is around 200 tons, with a similar injection rate that would be 80 tons per day. And we are predicting at first is 500 psi at the wellhead. And then from the first well, we are having lesson learned that our wellhead injections actually is not that low. So what we're having is our wellhead pressure would be in the range of 800 to 850 psi, like what we had in here. The soaking period for the first well, we are designing for 7 days, in which at the actual one, for the GTP 161, we end up with the soaking into 14 days. So that with the lesson learned from the first well, and that's why we are doing the design of the GTP 137 as the second well, exactly the same that we were doing the soaking period for 14 days as well. The incremental oil and the utilization factor that we were having here, that's estimations that what we had, 700 STB as well for the 300 STB for the GTP 137, with the range of utilization factor is around 5 to 10 MSCF per STB. From the right bottom side, this is actually the models from the reservoir engineering perspective that we are using for that. We were using CMG at that time, and then we are using the rectangular mode to simulate as part of our dynamic simulations. I would like to emphasize as well that with the dynamic simulations, we are having a lot of great help from our project collaborator from JOGMEC, in addition for us to get a very optimum design, and then we can perform the CO2 and PAF in a smoothly manner that time. So for the next one, I would like to explain about how the workflow and the timeline for both wells, in which we can see over here, the upper part is the timeline workflow actual one for the GTP 161. As we can see over here, it started from the October, and then the injections, if we can see that how long is the well preparations up to the injections period. As you can see here, we are having a very tight preparation schedule at that time. We were preparing like a first week of October, and we were having around 1 month, I think, for the preparations at RC survey, and then up until the Huff and Puff CO2 injections. And then this is in comparisons, we were doing up to 3 months of the productions monitoring. Since we are using the artificial lift, so then at the very first, after the POP, and then we goes directly to install the artificial lift. There are 2 types of artificial lift that we are using for the first well, which is the gas lift for 2 months, and then we are continuing to change the artificial lift into the ESP at the following months in February. And then for the GTP 137, we are so lucky that we can have an opportunity to have 2 wells sequentially in 1 year. So if you're doing the first well in October, end of October, and then for the next following 2 months, we managed to do the second well successfully in end of December. So then by today, I will say on behalf as well for PERTAMINA and JOGMEC, we were proudly to have that we are having 2 case studies of CO2 injections Huff and Puff in PERTAMINA. So that is our timeline. And then actually this is a pretty technical, and then but I would like to share you about how the exactly workflow that we had for the operationally. So I'd like to start actually only for the left side one. This is the first well. The operations that we were having, actually we divided into 4 stages. It become the pre-work, and then the CO2 injections, the stocking period, and then it ends up with the put on production period. The comparisons between the left, the first well and the second well, the difference is only about the RST. RST is reservoir saturation tool, in which for the first well, we run it after we did the bleed off. But based on the lesson learned, for the second well, we run the RST directly when we open the well. So I will speed it up a bit. And then how about the main injections for those 2 wells? The main injections for those 2 wells, as we knew that the plan of the very first, as we are doing that, not with the flow line, but we were doing the liquid transportations from the liquefaction plant, which is the Subang plant as the CO2 capture facilities. And then after that, we transport that one, and then we goes directly to inject it into our wells. In this case, the both of the wells. This one, actually, the schematic on how we can explain about the technically or operational workflow in this case. So this is actually the ISO tank, and this is the ISO tank at the upper part. This is the ISO tank 1, 2, 3, and 4. One ISO tank would be, the volume would be around 20 tons of CO2. It means when we were having 200 tons of the ISO tank, it means we need to utilize 10 ISO tank. And then the ISO tank, it goes into the pump. This is the pump 1 and the pump 2. We, in every stages, we were having the pressures gauge as well the temperatures for us for having the detail and the exact phase behavior of our CO2, bring all the process. So after it goes from the pump, it goes to the evaporator here, and then it goes to the electric heater, and then after the electric heater, it goes directly to the wellhead to be pumped into the reservoir. From here, from the ISO tank, the phase is the liquid, and then goes into the evaporator and the electric heater. The output from the electric heater is we are doing as the gas phase with the pressures of 850 with the temperatures of 15 degrees Celsius. And then what we are expecting when we were touching the perforations, it will in the supercritical phase of the CO2. So this is some footage of how it looks for the pump, the evaporation, the vaporizers, the electric heater, and also the wellhead in this case. So this is
the footage of the locations, and then I would like to jump into details about how the operations activities that we were doing during pre as well for the post operations. And then the data analysis as well, what we are preparing when we were trying to attempt to do the injections is, as we can see, this is the wellhead. When you are seeing the connections line that we had here, the rig that we were using is the rig that we are using for the pre-work. So to be emphasized here, when we were doing the CO2 injections, we will do that as a rig, or we are not using the rig. But the rig will be used for the pre-work and then as well for the post CO2 injections. Then they need to retrieve the packer and then to install the artificial lift after the CO2 injections. We are utilizing the testing unit over here. It's called the EPF, like early productions facilities. Probably the objective for us using the EPF is to separate when we were having the flow back from the wells itself. So this flow back, it will having us to monitor how much is the gas and then how much the liquid, as well for us getting the samples from the flow back period or the puff period. The next one, this EPF, it will consist of the gas separator. And then the gas separator, we were monitoring the rate. It's still a bit quite old ways for using the Barton chart, but this is the unit that we are using. And then with this Barton chart, we will monitoring, or we will calculating on how much the gas that's been produced during the flow back. And then this liquid tank, the measurements is as well to have an understanding about what will be the liquid measurement. Luckily, at the first one, the second well, we are having the oil back, the oil productions in this case at the very early stage from the first well. And then to prepare preparations, we were having the flare pit over here. The flare pit we are using since at the very first, when we're doing the puff, we would have some variety concentrations of the gas associate. As well, we also have like high concentrations of the CO2 at the first 5 days of the puff, of the put on production stage. And then this data analysis is something that we want to have it as a analysis qualitatively that we can measure in the lab. As we can see over here, this is the gas bomb for us to taking the gas sampling. This is, we are having the liquid sampling, and then at these bottles, we will have some sampling either for the condensate, which is consists of the oil, as well the water on it. This is actually how we were having the sample for the liquid sampling. As you can see here, we are so gladly that at the very first that we were having such a good sampling, that after that we will conduct an analysis in our lab, in PERTAMINA lab in Jakarta. In continuation, this is an example of the sample that we are taking from the field, from the wells. This is all the water, and then as well, this is all the oil, and this is all the equipment that we are preparing in our lab in Jatibarang to measure all the data that we require. Some examples of the analysis that we are doing is the gas compositions, oil compositions, PVT for the oil, like the viscosity, specific gravity, as well salinity, and some of the water analysis that we are having in all the samples there. If anyone would like to see how it behaves it looks like for the tubing as well for the packer. This is actually the visualizations of the tubing after we retrieve it from the CO2 injections. we are having some, if it's going to be an orange, and probably do we have rust? Yes, probably we were having a rust, but for a short period of time, it's not giving any significant damage to our tubular as well our equipment on locations at that time. And then this is the bed packer, and for the operationally, we were using EMR. EMR is the gauge to monitor the pressures as well the temperatures downhole. So in any operations that we conduct previously in 2 wells, we can have, and we are having monitoring data directly from the bottom hole data, in which that will consist of pressures and also the temperatures. So the operations challenges here is going to be my last 2 slides. Indeed, we are having the operational challenges. One of it is when we were talking about onshore operation, we're dealing with bad road conditions. As we can see, the ISO tank is big like a stuck in the road. So we need to do something to ensure it's using some crane as well as excavator to push the ISO tank to be not like a subsidence at that time. It's stranded ISO tank at that time. Sorry. And then the next ones would be production test. Since we are using some old EPF, probably for the next operational in other area in PERTAMINA, we will strongly recommend for having as the digitization one. So lesson learned that we are having, we consider that from the subsurface and operational. From the subsurface point of view, we are still emphasizing that Huff and Puff need for having continuations, in which continuations would be the pilot CO2 injections. In this case, we'll need 2 wells, and then it needs to be flood to have an interference between those 2 wells, each of them. So one becoming injector, and then the other one becoming the producers. Then the next one will be the comprehensive geochemical study will be required. It will include the scale occurrence, how the CO2 solubility in water, as well the asphalting test that probably in case by case or field by field, due to the CO2 injections, it will trigger some asphalting in the reservoir. It's not always going to be the same, but it needs to be evaluated or studied before we are doing the CO2 flooding. From the operational perspective point of view, the well integrity as well for the pre-work, it's mandatory to be held. And then for the CO2 pumping equipment inspections, is another mandatory performance checks that we need to do prior to do the CO2, prior to send to locations actually. So we need to ensure that all the equipment are working in a good conditions. The third one would be the CO2 liquid as a consumables when we were doing the Huff and Puff, need for having a clear arrangements. So we can have continuous operations, and if we are talking about the ISO tank, we would not to have like an empty ISO tank without any backup. So that would be the lesson learned that we are capturing from the Huff and Puff CO2 injections in Jati Barang. So that would be my last slide, since I would like to give all the time back to our moderator, Pak Sidemen. So apologize for having a pretty long, and hopefully it could have additional idea about how in technical point of view of the CO2 injections Huff and Puff in Jati Barang. Thank you so much, Pak Sidemen. That will be my slide. Thank you.
Thank you very much, Bu Debby, for a comprehensive presentation. I think we have maybe 9 questions already in the Q&A box. So, but you may ask it later, I think. So, before we go to Q&A session, with us, we have Mr. Kaswaki Mikami, Reservoir Engineer and Deputy Director of Subsurface Division Hydrogen and CCS Project Department of JOGMEC. He has a long experience in EOR project and also involved in various CCUS project. So JOGMEC also previously conducted up and up study in offshore of Vietnam and also in Japan in Minabe-Aga oil field in Niigata. The study in Vietnam is also successful. It it's possible to increase the production almost 32 million barrels of oil, but maybe not produced because the cost constraint. I would like to invite Mr. Kazuaki Mikami to further elaborate the possibility of up and PAP for increasing production and reducing emission. Mr. Mikami, please.
Okay, thank you for your introduction, Dr. Gusti Sidman. And thank you, Ms. Mary and Ms. Debby for your impressive presentation. And thank you all the participants for joining us today. Let me introduce myself briefly. I am Kazuaki Mikami, Reservoir Engineer from JOGMEC. And it's a great honor for me to make some comments for this knowledge sharing session today. And as Ms. Mary mentioned, this Tibaran CO2 Huff and PAP project is a joint project between JOGMEC and PERTAMINA. And actually, I'm also a member of the this Jatibaran project team. So today I would like to make some technical comments as a project partner. So I would like to start from a general comment. As you may know, from the reservoir engineering point of view, CO2 EOR is much more complex process compared to pure CCS, because we need to consider a three-phase flow, which is CO2, oil, and water, including the interaction between CO2 and oil. And that is a difference from pure CCS. So for CO2 EOR, CO2 Huff and PAP is proven and effective technology. I think somebody asked the question that CO2 Huff and PAP is new technology or not. Actually, it is not new technology. It is already proven and effective technology, especially to validate the oil and CO2 interaction on site with much less cost and influence to existing facility compared to continuous CO2 injection, such as a large-scale pilot test. But of course, there are always pros and cons. But I believe the cost effectiveness is very important for a pilot purpose, since it's not easy to make a decision to proceed with a field pilot test in many projects because of the required investment for that. So I think CO2 Huff and PAP is a good starting point for field implementation of CO2 EOR. And in addition, laboratory experiments and good reservoir characterization are also very important as usual. But on-site data obtained from a small scale could give us more confidence for actual CO2 performance, as PERTAMINA demonstrated in the Jatibaran project. And as Dr. Gusti Sidman suggested, talking about JOGMEC experience, we also have some experience in CO2 injection in the past in Japan, Vietnam, and other countries. And based on our experience, there is less surprise during CO2 injection, but production behavior could be very different from our original expectation, which is also related to the complexity of the CO2 EOR process. So honestly speaking, even for this Jatibaran project, our prediction before the pilot test was a bit different from the actual performance. And another important point is monitoring. As Ms. Debby presented, careful design for production monitoring is also very important, having good quality data. And depending on well status and well productivity and artificial lifting, we need to optimize monitoring strategy, including sampling frequency and also the analysis. And this is also an important point for CO2 EOR as CCS, since we need to monitor CO2 flow in the system accurately for CCU reservoirs. And at the last, our JOGMEC plans to carry out similar CO2 Huff and Puff in Japan within this year with impacts. Hope we can share the additional experience with audience through this wonderful network. So this is in a brief comment from myself. So hope we can have discussion with audience today.
Okay, thank you very much, Mr. Mikami, for a very insight. Then, because the time limitation, now we can go direct to 11 question here to Bu Mary, also Bu Debby, and also maybe Mikami-san also could ask us to answer. Basically, the question is regarding the future plan of PERTAMINA. Will PERTAMINA conduct Huff and Puff or EOR CO2 in other region? And then the second question is regarding what of the cost of using CO2 in EOR, maybe cost per barrel oil produced. And then the important question also, because we expect that CCUS EOR could serve as media to store CO2 also. There are two questions related to this issue. PERTAMINA treated the liquid CO2 and to measure CO2. And then some clarification regarding the material of the tubing. There's carbon steel or stainless steel. And then I think also a question regarding the depth of the well. So please, Bu Debby, Bu Mary, and also Mikami-san, you have each of you have 3 or 4 minutes to answer the question. Maybe start with Bu Mary, please, Bu Mary. I think here the question maybe for you is maybe you can answer the first question. Will there any plan to Huff and Puff in the future by PERTAMINA in other field?
Yes. Okay. Thank you for the question. It's a very good question. Yeah. I will answer for this one. The rest will be answered by Mikami and Debby. For the next plan for PERTAMINA, yes, we have several plans for the CO2 EOR actually, and one of it, the nearest one, is in West Java also. Yeah, maybe I can mention the name of the field. Yeah, the Sukawati one. Actually, we already have a long study for this, for the implementation of CO2 EOR. And with the experience from Jatibarang field, Huff and Puff, we see that this step, Huff and Puff, is really is as a important part to that we can get more data and more confidence level. Yeah, when we come into the next step for the CO2 EOR, such as for the pilot and also for the full field. Yeah. Like Kami mentioned before also that this will help us I can say optimize the way, the method that we can use when we do the fulfill scale for the implementation. So we in near future, the answer is that we will have the other, because we see it is quite beneficial and important to do before pilot or the fulfill. And it's also still in Java Island. Thank you.
Could you answer the
Yes.
question regarding what
Okay.
the depth of the well, and then
The next, okay. I will like to answer. Hopefully, I could answer that sequentially, and then for sure I would like to ask my project collaborator as well, our partner Mikami-san, for the next questions. So I would like to start with how the depth of the well is around 1,000 feet or 1,100 meters. Sorry, 1,100 meters or 3,000 feet in this case. So that is the depth of this reservoir, the lapisan F or the F reservoir. So, and then the second one is the confirm of the tubing grade that we were using for the CO2 Huff and Puff. We were using it's not chrome, it's carbon steel. If I'm not mistaken, we are using, I think it's around 880 for the type of the tubing. And then I would like to answer as well in this one is the source of the CO2 being used for the Huff and Puff. I would like to emphasize for this Huff and Puff, we were using the CO2 liquid that we get from the CO2 liquefaction plant. So it will send to locations with the tracking. And then how much volume of CO2 used per barrel of oil produced, utilization factor that we are having for those both wells are around 8 to 9 MSCF per 1 barrel. That's what we had for this Huff and Puff. And then I would like to have apologize for the overall cost of this operations. Is we couldn't share it since it will related to some of our disclosure agreement that we could not share yet for these CO2 Huff and Puff operations. But please feel free to contact either me personally or privately, so I probably could manage, or Mikami-san to manage to answer the questions. And then there's a questions about any impurities, H2S. For our case, in the CO2 stream. In the CO2 stream that we're using 99.5% of the CO2. So we don't have impurities such as H2S in our stream of the CO2 that we were pumping while using the Huff and Puff CO2 in those two wells. So I think for the next questions, I would like to give this opportunity to our partner, Mikami-san, probably, if you want to have some thoughts on several questions that we have now.
But before we move to Mikami-san, how about the CO2 leakage? Or do you PERTAMINA
there is
monitor?
Leakage? I will say that, as mentioned, with the equipment that we're using, the CO2 leakage is we were connecting the EPF. The EPF is the early production facilities. So during the flowback, all the flowback from the well, we connecting that directly into the gas separator, as I put in the slides. So I would not to say that as a CO2 leakage, but we are monitoring the gas concentrations from the flowback. As you saw that we can see the flare pit. The flare pit that we are having is the other connections from our testing unit, so that whenever we were having some high LL, so we can flare it.
So I would not say that we are having the CO2 leakage, but indeed, for the first 3 to 5 days, we are having high concentrations of CO2 due to we were pumping in for 2.5 days in this case.
From the project execution, did PERTAMINA calculate how much actually the CO2 remain in the underground and how much go to the surface with the oil?
The 200 tons would be equals to 4.4 mmSCF. So based on our productions monitoring, we managed to have 23% of the CO2 recover back into the surface, and then the remaining 70% plus is still there. We could not. We will assume that is still down there in the reservoir. Probably mechanisms would have to have some thoughts on this.
No, I don't have any additional for that.
Yes.
Yes. We basically recovered about 30% of injected CO2, but the 70% remains in the reservoir. Actually, it is a bit low recovery compared to other projects. So we are investigating what is the cause of the low recovery of CO2. Okay, and I would like to answer some questions that Debby-san haven't answered. So I think one question about what is a factor to park soaking period. I think this is a very good question. Actually, we had a similar discussion with PERTAMINA, what is the optimum soaking period for this project. But actually, this is more like practical factor. So it is hard to answer what is the optimum soaking period for this project. But so we need more like trial and error to optimize soaking period. In US, in some projects, they tried to minimize soaking period. So sometimes they just inject CO2 and produce without soaking period. But in this project, as a reference, we tried from 1 to 2 weeks soaking time. Okay, and another question, I think, the last question probably, how much on average oil can be extracted for each ton of CO2 injected? To answer this question, I think we may need to explain about our utilization factor. I think in PERTAMINA's presentation, they already showed CO2 utilization factor. The figure shows efficiency of oil recovery for each CO2 injected volume. And in our project, CO2 utilization factor is from 5 to 10, as Miss Debby showed. So that means we needed to inject about 5 MSCF, from 5 MSCF to 10 MSCF to recover 1 stock tank barrel of oil. So that's our answer for this question. I think we already answered all questions, if I'm not mistaken.
I think we still have one question from Takai-san. Does the Huff and Puff technology is the first technology all over the world? Yeah, maybe I could assist also to answer this question. Is it not the first technology, I think, because the technology has already exists since 60. I think China now use it extensively. Also, Canada use it to produce oil from tight oil and unconventional oil. But because the cost constraint maybe not well developed for certain period of time. But now, as the opportunity to use Huff and Puff also, besides to produce the oil, but also to store the CO2, maybe this technology will useful for us to meet energy security and also reduce emission from oil and gas production. I think that's my additional comment for the Q&A question, but let me check whether we still have a new question from the participant. But I think one question come again from Morisang, I think. How does RST log vary before and after the up and pop? Is Debby or Mikami-san could answer this question?
Yes, actually, to answer this, how does RST log vary before and after the half and puff? Actually, since yes, we were performing the RST log before and after the injections, and indeed we are having some changes or distinctive difference before and after about for the saturations of the oil as well the gas before and after the half and puff injections. But since we are still having some detailed evaluations in technical POV, point of view, so that's why we are not yet sharing any data so far about how the analysis and everything for the half and puff technical evaluations. Hopefully within a few months from now, after we are having an agreement with our partner as well, so we can have it more publicly about to share about how it behaves in terms of the technical evaluations after the half and puff. Probably Mikami-san wants to add some more, please.
No, this one, but yes, we could observe, the difference between before and after CO2 injection for RST, and it was, one of the, important data we could obtain from this CO2 half and puff test. Yeah.
Okay.
I think, thank you very much. I think we answer all questions except one more. I think participant would like to have a copy of the slide presentation. Is it possible? I think the answer should come from Bu Mary or Bu Debby. Is it possible for the participant to have a copy of your presentation?
For my presentation, it is possible. But for Debby presentation, maybe we need to check again, some slide. Yeah, Debby.
Okay.
And then we can share part of it.
Yeah. In that case, just please send the presentation file to us, to the secretariat, and then secretariat will distribute it to the participant. Thank you very much. If there is no any
we
more.
are having raised hand from Pumin, actually.
Pumin, no. I didn't see it. Please, Dr. Pumin, please, if you have any more comments.
Thank you so much, Dr. Gusti and Ibu Debby, as well as Ibu Mary, and also the expert from Mikami-san. I think this is a very nice presentation and sharing knowledge. But I just want to know that the two questions is the injection CO2 is allowed within the current permit of oil and gas production. That is one thing, or you need a new regulation if it's going to be commercialized, this one. Second, I think we learned from JOGMEC also that they are doing, but they inject too well from water, one side water CO2, and they observe production on the other side of the well. I think this is a new thing that we learned has in past. I think it's a low cost that will be very good for Indonesia. But again, I just want to know is, do we calculate the cycle of net emission? Because when you observe production after soaking period, you observe production. And within that, I think the backflow also include the flaring, including emission and others. Do we also calculate the cycle of CO2? How much we able to put the CO2 underground? I think that will be very important. Do we also establish kind of method within has and pass? That is my question. Yeah, thank you.
And also Kimura-san also raised his hand. I think, please, Kimura-san. before after Kiprasang, maybe Bu Debby will answer.
Okay, thank you very much. And maybe my question is similar to the Pumit. And I'm not engineer. Thank you very much. It's Ms. Debby and Ms. Mary. Very, very interesting and excellent presentations. And thank you very much. Mikao-san, it's a very appropriate comment to us. So I'm not engineer, and I'm not familiar with EOR, COR, and I have very preliminary primitive questions. So it is CO2 EOR is very good, so that inject action of the increased production apply to the this CO2 EOR in the same well or same field, so that once we inject the increased production of oil, and maybe some after 3 or 4 months, again inject the CO2. Then soaking and increase production of oil. So how many times usually we can apply the CO2 EOR to in the same well or same field, so that we can increase the storage of the CO2. First time 200, next time 200. So that's a very, very, sorry, I'm not engineer. It's a very low level question. Thank you very much.
Thank you.
Please, Bu Mary, Bu Debby, or Mikami-san.
Maybe I just want to comment about the regulation that Mr. Who asked the first?
And Mr. Dr. Han Pumin.
Oh yeah, Dr. Han Pumin. About the regulation. Actually, with the regulation now, yes, we can implement the CO2 EOR. It's just that about the, because people, when they talk about CCUS, they also link it to the carbon credit or carbon trading. Yeah. For that one, then we cannot use the regulation now. But for the CO2 EOR, it's already implement the regulation. So we can conduct CO2 to enhance the oil or enhance the gas with the regulation now. Maybe that is my answer.
Thank you, Ibu.
Thank you. Okay, the other maybe either Debby or Kami-san could answer it.
Thank you so much, Ibu Mary, for the regulations question, for the regulations answers. And then Pumin, apologize for I believe that you are having your second questions that is related for the operations. I believe if you don't mind to have some to repeat the questions, Pumin. I probably take it not too well at the very first when you say that. So,
thank you so much, Ibu Debby. I think we need to calculate the net emission that we able to store in the ground, because we just not consider the rate we're injecting, but also the emission that come along with production, enhanced oil and gas recovery. It's through the flare gas and other CO2 combined. That also, I think we need to calculate. So after all, how much we able to store the CO2 underground, that is the most important. Do we also establish such kind of calculation method? I think that will be important. Yeah.
I think that is also has been answers in the Q&A. Then is I think one of the we did calculating for net emissions, as mentioned, that from the 200 tons that we are injecting, that's equal to 4.4 MSCF. We managed to calculate with the production test that we had, that we managed to test, we managed to store around 70% from the 200 tons in the underground in the reservoir. And then including the one that we are flaring and everything, that's 30% of it, Bumin. So, but indeed, we are having every detailed calculations on how much we are injecting during the Huff and Puff, as well how much we were recovered either with the flare or either with the productions, and how much we were stored or estimated to be stored in the reservoir. But yes, we were having all those calculated qualitatively and then as well quantitatively from either from the lab, from the gas compositions, and as well from calculations from the production test unit. And then and we did that for both of the wells with a similar range of 70% is being stored in the reservoir, and then it's around 30% that we recovered back in the surface. That's all. Mikami-san, want to add some more in these questions from Fumi?
No addition. You're right. Basically, we managed to remain 70% of injected CO2 into the reservoir. So, but we haven't, included, flared gas during the production. So, it's just, based on the calculation of, CO2 injection and the production volume. So, okay. And about, okay, I'll go ahead.
We have a question regarding the calculation of CO2. In the calculation, is CO2 inside the oil extracted included? I think Ms. Debby already answered it. 30% CO2 released to the surface is come from CO2 in the oil production. I think that's the answer.
Yeah, I think we need to answer the questions from Kimura Sensei.
Okay, please.
So may I answer the question?
Please, Mikami-san. That's actually.
Okay. Thank you for your question, Kimura Sensei. I think that's a good question. But before answering your question, I want to highlight one thing. We implemented this CO2 Huff and Puff for pilot purpose, for data acquisition, and basically it is really hard to commercialize CO2 Huff and Puff. So basically CO2 Huff and Puff is to acquire data on site. That is our understanding. But in US, actually, there are several commercialized CO2 Huff and Puff projects. And in those projects, they inject CO2 cyclically. So as you mentioned, yeah, sometimes they inject CO2 more than 3 times for the same well.
Okay. Good.
So it can be also possible, but our primary purpose is data acquisition.
Yeah, okay. Data acquisition. Okay, thank you very much. Very good answer. Thank you very much, Mikami-san. Thank you.
You're welcome.
I think we come to almost to the end of this conference. If there is no more question, I would like to conclude this session, and I will not, due to time constraint, I will not like to draw some conclusion from the discussion, but allow me to thank you once again to distinguished speaker, Ibu Mary, Ibu Debby, and also Kaswaki Mikami-san, and also for distinguished participant who joined this sharing session with enthusiasm. And by saying that, I conclude this session and return the session to MC again. Ian, time is yours.
Thank you, Dr. Sideman, for lead the discussion session. We have heard from the experts today that not only from the technical perspective, but also solution provided from the Huff and Puff CO2 EOR to improve oil production and reduction at the same time. Then before we end today's conference, now I call upon Dr. Han Fu Min, Senior Energy Economist of ERIA to say a few words for closing remarks. Please, Dr. Fumin, the screen is yours.
Thank you so much, Dean. Confirm, do you hear me?
Yes, we
Yes,
can hear you clearly.
Thank you. Distinguished speakers, expert, ladies and gentlemen. First and foremost, on behalf of Asia CCUS Network, we are very grateful and thankful to the speaker from PERTAMINA who shared with us the experience of Huff and PASS EOR method and its application in the pilot projects. We also thank a commentator from JOGMEC who provide a good discussion and dialogue to this presentation. Today, we learn a lot about the steam injection Huff and PASS EOR methods by injecting heat energy in the steam phase to reduce oil viscosity and also reducing oil in the same oil field or oil well. The technology is known among the least cost, but it can only apply to certain, particularly oil field criteria, in which screening criteria need to be conducted carefully for selecting well candidate with the low performance. EOR steam injection Huff and PASS method consists of 3 stages: period, soaking period, and production period. In the experiment field of Jati Barang field in Indonesia, it's all with 2 well experiment. Injection period around 2.5 days and soaking vary from 1 week to 2 weeks for these 2 fields. And after that, we observe the production rate within the 3 months. There are 3 parameters used to analyze the production response after EOR steam injection, such as productivity index, inflow performance relation curve, and production rate test. These parameters show the comparison before and after EOR injection, steam injection. What we learned from Indonesia today is to move ahead with Huff and PASS to several commitments and collaboration, such as the company management commitment toward net zero emission, government support in this case, particularly AMIA and the MIGAS. We need also have a good collaboration, international collaboration on knowledge sharing, expertise, and also a funding. And we need a good partnership to share project costs and benefit and sharing the risk and got the right required technology capability to do this. Technology improvement and optimization to reduce cost is necessary. And finally, we need to have a good performance monitoring data for this kind of pilot in order to go for the larger scale. For economic of scale of Huff and PASS, the CO2 input is critical to reduce the cost. To obtain the cheap cost of CO2 will require a good CO2 value chain from capturing, transportation to injection well field. Thus, it highlights the necessity for CO2 value chain infrastructure in Indonesia immediately. It is also very important to note that EOR Huff and PASS, as we discussed, that from this experiment can store at least 70% of CO2 total injection into depleted oil and gas field in the experiment. So about 30% of CO2 are released back from the backflow production. But in the future, it will be good to find a way to put back the CO2 flaring back to the ground. Last but not least, I would like to take this opportunity to thank the JOGMEC, to the PERTAMINA JOGMEC for their large contribution to this learning session. And let me once again thank all the participants who joined this important conference. And I wish you a wonderful day. Thank you, and back to you, Dean. Thank you so much, by the way.
Thank you, Dr. Fumin, for your closing remark. And now we have come to the end of the conference. Thank you to our wonderful panelists, Ms. Marteighianti, Mr. Halinda, Mr. Mikami, Dr. Sideman, Shigeru Kimura-san, Sensei, and then Mr. Han Fumin. We are very honored to have our speakers sharing their view and expertise with us. Please visit our website at www.asiaccusnetwork.org to receive all about ASEAN news updates and upcoming events. We are looking forward to seeing you in the upcoming knowledge sharing conference and other ASEAN activities. With that, this conference is officially closed. Thank you, everyone.
Thank you so much.
Thank you, Dian, and thank you, Miss Mary. Thank you,
Thank you very
Debbie.
much.
Thank you, Mikami-san. Thank you,
you.
Gusti. Thank you very much.
Terima kasih.
Mary.
Thank you, audience.
Terima kasih.
Bye.
Thank you, Sensei. Thank you.
Thank you.